Bonding characteristics of the nitrogen atoms in organic compounds. An understanding of the bonding characteristics of the nitrogen atom is a prerequisite to the study of amines and amides. So nakabutang diha nga before ta makaproceed na sabton ang amines ug amides, first and foremost, need na to sabton ang bonding characteristics sa nitrogen atom in anorganic compounds. It is because ang bonding characteristics of the nitrogen atom in anorganic compounds is isa na siya ka-foundation para mas masabtan or mas makomprehend na og tarong ang structure sa amines ug structure sa amides. Nitrogen is a member of group 5A of the periodic table, and it has 5 valence electrons and will form 3 covalent bonds to complete its octet of electrons. Thus, in organic chemistry, carbon forms 4 bonds, nitrogen forms 3 bonds, and oxygen forms 2 bonds. So makita na to diha nga ang carbon is naa siya 4 valence electrons, 4 covalent bonds, and no non-bonding electron pairs, while ang nitrogen is naa siya 5 valence electrons, 3 covalent bonds, and 1 non-bonding electron pair. And lastly, ang oxygen is naa siya 6 valence electrons, 2 covalent bonds, and 2 non-bonding electron pairs. Structures and classifications of amines. An amine is an organic derivative of ammonia, or ginaderive siya from the word ammonia, in which one or more alkyl, cycloalkyl, or aryl groups have replaced ammonia hydrogen atoms. Amines are classified as primary, secondary, or tertiary on the basis of how many hydrocarbon groups have replaced ammonia hydrogen atoms. So first is ang primary amine. A primary amine is an amine in which the nitrogen atom is bonded to one hydrocarbon group and 2 hydrogen atoms. The generalized formula for a primary amine is RNH2. One carbon-nitrogen bond is present. So makita na to diha sa example ang simplest structure sa primary amine in which ang iyang generalized formula is RNH2, in which ang nitrogen is bonded to one hydrocarbon group and 2 hydrogen atoms. So the next one is ang secondary amine. A secondary amine is an amine in which the nitrogen atom is bonded to 2 hydrocarbon groups and 1 hydrogen atom. The generalized formula for a secondary amine is R2NH. 2 carbon-nitrogen bond are present. So makita na to diya sa example ang simplest structure sa secondary amine in which ang iyang generalized formula is R2NH, in which ang nitrogen is bonded to 2 hydrocarbon groups and 1 hydrogen atom. And the last one is ang tertiary amine. A tertiary amine is an amine in which the nitrogen atom is bonded to 3 hydrocarbon groups and no hydrogen atom. The generalized formula for a tertiary amine is R3N. 3 carbon-nitrogen bond are present. So makita gihapon na to sa example ang simplest structure sa tertiary amine in which ang iyang generalized formula is R3N, in which ang nitrogen is bonded to 3 hydrocarbon groups and no hydrogen atom. The basis for the amine primary, secondary, tertiary classification system differs from that for alcohols. For alcohols, how many R groups are on a carbon atom, the hydroxyl-bearing atom is the determining factor. So maong nahimo na siya og tert butyl alcohol, it is because naa siya tulo ka CH3, which is ihang R groups, maong gitawag siya og tert or tertiary. And nahimo na siya og butyl, it is because naa siya upat ka substance. And nahimo na siya alcohol, it is because OH stands for alcohol. For amines, how many R groups are on the nitrogen atom is the determining factor. So maong nahimo na siya og tert butyl amine, it is because the same lang gihapon na siya tulo ka CH3, which is iyang R group, maong gitawag siya og tert or tertiary. And gitawag siya butyl, it is because naa siya upat ka substance. And gitawag siya og amine, it is because NH2 stands for amine.
So next is the functional group present in primary amines. So kani siya, the NH2 group is called as the amino group. So kaning amino group is the functional group, which is the NH2 group. So the secondary and the tertiary amines possess the substitute amino group. So makita dinhi sa screen, kani siya, makita dinhi sa screen ang kaning example. So dinhi na ay amino group, and then sa pikas na ay monosubstitute amino group. And then sa pinakalas is the disubstitute amino group. The next is, makita nyo dito sa screen, ang example picture sa isa ka molecule which is the ammonia. So, makita niyo dito na ay tulo ka hydrogen and then ang center is the nitrogen. So, usoon na to pagkuha sa kaning name ani niya. So, makita nyo dito kay na tulo ka hydrogen. and then na isa ka nitrogen. So ibutang na to N, H, and 3. Nganong na ay 3? So 3 kay tulo ka hydrogen, and then sa first is N is the nitrogen. So next is the primary amine. So makita niyo diha sa screen ang example picture sa primary amine. So ang pagkuha aning kanihang sa ubos is same lang siya sa ammonia. And then sunod sa primary amine is the secondary amine, and then the last is the tertiary amine. Cyclic amines exist such as compounds which are heterocyclic compounds are always either secondary and tertiary amines. So next is makita niyo diya sa screen. So nganong 2 cyclic amine man siya. So kani siya is kuan siya kaning secondary amine kay ano man na N which is the nitrogen and then H is the hydrogen. So tulo man siya ka compound. So ibutang na to 2 cyclic amine. And then sa picas is the 3 cyclic amine. So 3 cyclic amine kay tertiary siya, tulo ka buok ka compound which is the CH3. And then amines, nomenclature amines. So amines also classified as primary, secondary, tertiary. So it depends on the number of organic substituents that are attached on the nitrogen. So maghatag ko o kini example. Siya ang katong example sa primary amine. So unsa na to pagkuha sa common name aning CH3 and NH2. So ang pag-name ani niya is methyl amine. Methyl because isa lang. And the next is secondary amine. So makita nyo diha na CH3, NH, and CH3. Since duha man sila kabuok nga same CH3, so ibutang na to dimethyl amine. Then isa pa ka example kay kani siya. So unsa ni siya? So kani siya is isopropyl amine. So next is the IUPAC rules for naming amine. So muna yung example. So rule number 1 is select the parent carbon chain to the longest chain to which the nitrogen atom is attached. So magsugod ta og kining count dinhi sa pinakataas which is the CH3, CH2, CH, CH3. So the rule number 2 is name the parent chain by changing the E ending of the corresponding alkane name to amine. So 4 man siya which is the butane. So, instead na naa siya E, sa pinakalas, i-change nato siya og amine. So, butanamine. And then, the rule number 3, number the parent chain from the end nearest the nitrogen atom. So, mamani siya ang kining end sa longest chain. So, diri ata magsugod og count 1, 2. So, 2, ibutang nato din niya. So, 2 butanamine. So, rule number 4, the position of the attachment of the nitrogen atom is indicated by a number in front of the parent chain name. So, ang pagsulat nato sa kaning parent chain o ang sa kaning number is naka sentro siya sa kaning nitrogen atom dinhi sa baba. So, butan nato diha 2-butanamine. Naka-sentro yun na siya ha. And then next is the diamines. So makita nato diri sa example na 4 carbon chain of 2 amino groups. So 2 amino groups is butane diamine. So klaro na kaayo nga ang 2 amino groups is butane diamines. So sa kaning ihang pag-naming is na 1 is because ang kaning 4 carbon chain is same lang sila og kining compound which is the CH2. And then 4 is butane and then dash butane diamine. And then last is the secondary and tertiary amines are named as the N primary amine. So the longest carbon group bonded to nitrogen is used as the parentamine's name. So nako example diri sa screen makita niyo diha nga ang dinhi ana side is the ethyl group and then diri ana side is propyl group and then sa pinakataas is the methyl group. So we all know that ethyl comes before methyl and methyl comes before propyl. So, ang pag-naming ani, iuna na to ang ethyl, and then next is the methyl, and then next is propyl, and then the last which is the amines. So, dili po na to kalimtan na before ta magbutang og kining ethyl, ibutang sa nato ang N which is the substitute of the primary amines. So, mao lang to. Thank you.
Good afternoon guys, my name is Nilberto Nueva and I'm gonna discuss the amino group and the isomerism in amines. So, in amines, traditionally functional group are presented. The amine group is treated as a substituent and NH2 group is called an amino group. So, ang amino guys kay mao ni ang naay bond na duha ka buok na hydrogen. This is the NH2. Sa atong structure guys kay naatay na siya functional group guys ba na nasagol. Matawag siya na in amines where additionally functional groups are present. So which is kaning blue. Tama na ng blue guys. Mga na other functional group is the mga ang ganang blue guys kay mga na ang carboxylic acid. So mga nang naming niya which is the 3-amino pentane which is the 5 man kabuok na carbon atong na so which is the pentane. So pentan ioic acid and ioic acid siya pabasa sa ngana. Then next is the simplest aromatic amine, benzene ring bearing an amino group is called so ang tawag daw sa benzene kung naa siya sa attachment na amino group kay ang tawag sa is aniline. So other simple aromatic amines are named as derives of aniline. So aniline. So diriyan sa tong structure guys na ginatay nakita tulo ka buok example sa aniline o i-naming na siya. So mao ni ang atong aniline guys kaning pinakauna. Mao na ang structure niya. Matawag siya na aniline. Na siya benzene ring then sa attachment niya kay NH2. So tawag sa iya kay aniline. Aniline. Then so diri sa second structure namin ay chloro. So meta ang tawag siya kay 1, 2, 3. So meta. Katulo ang chloro. So meta chloro aniline. Next kay other example is kanang duha ka buok chloro. So dichloro aniline. So sa nakatungtong man ang chloro sa 2 and 3 chloro. 2-3 dichloro. Then aniline kay duha mga chloro. So aniline. And next kay space filming model of aniline. The simplest aromatic amine. Aromatic amines include ding aniline are generally toxic. Toxic daw na ang aniline guys kanang then they are readily absorbed through the skin kanang mga aromatic na like maumon or patay na isda sa patay sa isda na. Then in secondary and tertiary aromatic amines, additional group or group attached to the nitrogen atoms are located using a capital N. So kung makita daw nimo na ay group attached ba sa ato ang amine, kaya ang tawag din aniline man siya guys kay naamay na attach na bond with the string. So aniline siya tawag so naamay na attach sa secondary ra ba kay kung naay ma-attach sa amine niya is secondary tertiary then N is mag-use data of N capital N then N capital N and dash ethyl aniline kay dawa man naman siya group attach. So ang group attach niya kay which is the ethyl. So ethyl aniline. So sa pinakaduwang instruction so secondary duwa kabuok na dimethyl aniline. 3 so nakatungtong man sa 3 ang ato ang amine. So aniline kay nakatungtong sa ang ato ang amine ba kay nakatungtong sa aniline. So naman siya benzene ring. So aniline ang tawag sa iya. So na siya sa attachment na isa ka buok na carbon ang ato ang NH so which is dimethyl kay because sagol naman siya, dimethyl aniline. So isomerism for amines. Constitutional isomerism in amines can arise from several causes. Different carbon atoms arrangements produce isomers as in. So dria guys kay naatay kita simple of naming sa amin. So dria kay naatay pero atong functional, so makabuok na carbon, then itong ang carbon sa first sa nitric carbon, then 1, then 5 which is the pentane, so pentan amine. So then sa second structure is 2 methyl 1 sa duwa magabok methyl dili duwa de kon methyl siya methyl kaya naman siya substituent ng carbon isa 2 dash methyl then dash 1 butane amine. Next is the four secondary and tertiary amines. Different partitioning of carbon atoms among the carbon chains presents procedures constitutional isomers. There are three C4 or a carbon 4 secondary amines. This is the carbon atom, but partitioning can be two ethyl groups, propyl group and a methyl group, or an isopropyl group and a methyl group. So three guys kayo. Just in sa akong gingon kaganina kay duwa siya ba anang if na ay tawagan ni carbon version can be two ethyl groups or na ethyl propyl group sa saka nitrogen which is the NH, then duwa ka buok niyang ethyl group mo na siya, so group mo siya, so N dash ethyl ethane kay makabuok, so ethane amine, ethane naman siya duwa carbon ang atong longest chain, so duwa man kabuok ethane amine, and NH, so diriya na siya isa ka partitioning can be two ethyl groups, propyl group and a methyl group, or an isopropyl group and a methyl group. So three guys kayo. Just in sa akong gingon kaganina kay duwa siya ba anang if na ay tawagan ni carbon version ng can be two ethyl groups or na ethyl propyl group sa saka nitrogen which is the NH, then duwa ka buok niyang ethyl group mo na siya, so group mo siya, so N dash ethyl ethane kay makabuok, so ethane amine, ethane naman siya duwa carbon ang atong longest chain, so duwa man kabuok, ethane amine, and NH, so diriya na siya sa ka-methyl, and duwa ka, so ang longest chain na to ay which is kaning carbon, and 1, so 1, 2, 3, so na may methyl ang NH, so nabutang siya sa N, then ang N tapos methyl kaning isa ka buok sa kilid niya, so methyl 1 kay nakatungtong siya sa 1 itong carbon instrument no, carbon is propane kay because pilo ka carbon atong longest chain, propane amine, So, amine. The next, na siya is substituent na isa sa pinakababa. So, N118 propane. Propane atong longest chain because 1, 2, 3. So, pinakababa. Pinakababa na duct na propane. So, 1 N dash methane dash 2. So 2 man nakatungtong ato ang methane. Methane. So propane amine. Next guy. Say physical state summary of branch primary amines room temperature and room pressure. So sa amines daw kayo state summary branch primary room. The methyl amines or mono, di and tri are ethylamine are gases at the room temperature and have ammonia-like odors. Kato ang ingon na ang bawon niya is sa order of fish rows, a few amines, particular amines have strong disagreeable odors. The foul odor arising from dead fish or dying fish are due to amines released by the bacteria disposed of a protein. Two of those other furious compounds are diamines, proteasome, and cadaverine. So, sa extraction guys, kaning sa baba ba, mananduabo, pwede nimo siya matawag na proteasine ang tawag sa iya if na siya upat ka carbon o duwa ka buok sa kilid na amines. So ang tawag daw sa iya is proteasine. So ang other ko niya ang naming niya is ganing duwa buok o ganing sa kilid guys, ganing cardiverine ang tawag siguro na cardiverine na siya 5 ka carbon atoms na carbon addition to duwa ka buok natin, duwa ka buok na nitrogen. So 5 ka carbon atoms din.
So structure and classification of amides. An amide is a carbocyclic acid derivative in which a carboxyl OH group has been replaced with an amino or substituted amino group. The amide functional group is thus depending on the degree of substitution. Amides, like amines, can be classified as primary 1 degree, secondary 2 degree, tertiary 3 degree, depending on how hydrogen atoms are attached to the nitrogen atom. A primary amide is an amide in which 2 hydrogen atoms are bonded to the amide nitrogen atom. Such amides are also called unsubstituted amide. A secondary amide is an amide in which an alkyl or aryl group and a hydrogen atom are bonded to the amide nitrogen atom. Monosubstituted amide is another name for this type of amide. A tertiary amide is an example of which 2 alkyl or aryl groups and the hydrogen atoms are bonded to the amide nitrogen atom. Such amide disubstituted amides is the kind. So note, the difference between a 1 degree amide and a 2 degree amide is amide H versus R. And the difference between 2 degrees amide and a 38 amide, again, H versus R. The simplest amide has a hydrogen atom attached to an unsubstituted amide functional group. Next, in complicity are amides in which a methyl group is present. There are 2 of them in one with the methyl group attached to the carbon atom and the other with the methyl group attached with the nitrogen atom. The first of this structure is a 1 degree amide and the second structure is the 2nd degree amide. The structure of the simplest aromatic amide involves a benzene ring to which an unsubstituted amide functional group is attached. So the cyclic amide structures are possible examples of such structures include cyclic amides are called lactones, a term that parallels the use of the term lactones for cyclic esters. Lactone is a cyclic amide. As with lactones, the ring size of a lactone is indicated using a Greek letter. A lactone with 4-membered ring is a lactone B because the B carbon from the carbonyl group is bonded to the heteroatom O of the ring. A lactone with 5-membered ring is a G lactone because the G carbon is bonded to the heteroatom O of the ring system. The members of the penicillin family of antibiotics are having the structures of the B-lactam. So, siya ang example sa kanang B-lactam. Nagka-contain ang katong penicillin. Nomenclature for amides. For nomenclature purpose, both IUPAC and common amides are considered to be derivatives for carbocyclic acids. Hence, their names are based on the name of their parent carbocyclic acid. A similar procedure was used for naming esters. The rules are follows as rule number 1. The ending of the name of the carbocyclic acid is changed from IC or ic acid common or oic acid sa IUPAC to amide. For example, benzoic acid becomes benzamide. Benzamide na siya. That's rule number 2. The names of group attached to the nitrogen 28 and 38 amides are appended to the front of the base name using an N prefix as allocator.
Good day, I am the last reporter of our topic, and I'll be reporting the physical properties of amides. So these are a crucial aspect considered in understanding their behavior. So some of their behaviors are, one of those are the melting and boiling points. Amides typically have higher melting and boiling points compared to similar-sized hydrocarbons. This is due to the presence of hydrogen bonding between the amide functional groups. The stronger intermolecular forces require more energy to break during phase changes. Next behavior is the solubility. Amides are generally soluble in polar solvents due to their ability to form hydrogen bonds. However, solubility can decrease with increasing molecular size, as larger molecules have more non-polar regions. Last behavior is the odor. Some amides have distinctive odors. For example, furamide has characteristics of sweet odor. And lastly, some odor came from examples such as cosmetics and makeups.